Most of the time, these departments work locally, processing their own data without bothering the rest of the organization. This is what we call unconscious processing. For example, you can walk down the street while your motor cortex handles the complex mechanics of balance and gait, all without your conscious involvement. But what happens when something truly important occurs, like a car horn blaring or someone calling your name? That specific piece of information needs to be shared with everyone. GNW proposes that consciousness is what happens when information goes viral within the brain. A piece of sensory data, or maybe an internal thought, gains access to a central broadcasting system, a global workspace, composed of a network of long-range neurons, primarily in the prefrontal and parietal cortices. Once information enters this workspace, it is broadcast widely across the entire brain, becoming available to all the specialized departments. Your language center can now report on it. I hear a horn. Your memory department can search for context. That sounds close. And your planning committee can generate a response. I should jump back onto the sidewalk. According to GNW, this state of global information availability consciousness. This model makes clear, testable predictions. Neuroscientists can look for signatures of this global ignition. When a person becomes aware of a visual stimulus they were previously ignoring, we should see a sudden coordinated burst of activity across this widespread brain network. And that is precisely what brain imaging techniques like EEG and fMRI have shown. Unconscious stimuli trigger localized activity, but the moment of conscious recognition is accompanied by a late, large-scale brain signal. The theory provides a functional, concrete mechanism for what it means to be aware of something. It means that information has won a competition for access to the global stage of the mind. Crucially, GNW is entirely about architecture and information flow. It makes no special claims about the underlying physics. Any system, biological or artificial, that implements this architecture of specialized processors linked by a global broadcasting hub should, in principle, become conscious. If we were to build a robot with a similar cognitive architecture, it would report on its inner states, not because it was programmed to mimic a human, but because its internal information was being handled in the same globally accessible way. In the GNW view, the ghost in the machine is not a ghost at all. It's simply the executive summary delivered to the entire company at once. A second highly influential computational theory approaches the problem from a different, more philosophical angle. This is integrated information theory, or IIT. Instead of asking what consciousness, IIT starts by asking what consciousness. It identifies the essential properties of our own subjective experience. Every moment of consciousness is rich with detail. And yet it is experienced as a seamless, unified whole. You don't experience the color red separately from the shape of a ball. You experience a unified red ball. IIT proposes that any physical system that possesses these twin properties of information and integration must, by definition, be conscious. To formalize this, IIT introduces a mathematical measure called phi, or F.